In this tutorial, we will perform a first measurement using the embedded heliViewer. heliViewer 4 is a browser-based application that runs directly on the Helios device. No software installation is required. Simply open the device IP address in a web browser. The factory setting is 192.168.2.71. When opening the embedded heliViewer 4, you first need to sign in. Use operator as the username and Helio3DCam as the password. Then click Login to access the application. The home page provides an overview of the heli service and camera status. Additional sections provide access to the EEPROM, system logs, and scripts. For measurement and camera configuration, we open heliViewer 4. With the sample position below the camera, click Connect in the top left area. Once the camera is connected, click Setup in the top right area to start the setup wizard. The wizard guides us through the configuration required for the first measurement. The first step is the stage initialization. We first need to configure the illumination. In this example, we use user output 0 to control the light. Next, we select the interferometric objective. Here, a 2x objective is installed. Selecting the correct objective automatically configures relevant camera parameters, including the numerical aperture and wavelength correction. The camera offers various surface extraction modes. For this measurement, we simply use the recommended accelerated center of mass extraction method, which provides fast acquisition with good measurement quality. The next step is to find the sample surface. For this initial search, we use a large scan range. The available scan range depends on the selected target vertical spacing. We also initially use high illumination and exposure settings. This may result in a saturated image, but makes it easier to locate the surface. Before starting the scan, we define the approximate distance between the objective and the sample. In this example, the distance is approximately 42 millimeters. This information helps ensure that the objective cannot collide with the sample during the search. We can now perform the first measurement and locate the surface. Once the surface has been found, we optimize the measurement parameters. The amplitude threshold allows us to suppress pixels with insufficient signal and clearly identify the measured surface. The resulting topography also makes it easy to recognize, for example, whether the sample is tilted. We can now adapt the scan position and scan range to the actual surface. Reducing the scan range avoids acquiring unnecessary data and makes the measurement more efficient. The final optimization step is the exposure. After taking another measurement, we check the signal distribution and the number of saturated pixels. If necessary, the illumination or exposure can be reduced until a suitable signal level is reached. The setup wizard then provides a summary of the configured parameters, including the illumination, objective, extraction method, scan range, scan position, and exposure settings. The system is now ready for measurement. When starting an acquisition, the embedded viewer automatically switches from configuration mode to acquisition mode. The measured surface is displayed directly in the browser. Some configuration parameters are intentionally unavailable during acquisition. To modify these settings, simply switch back to configuration mode. This completes the basic setup and first image acquisition using the embedded heliViewer.